Hello again. In this part, we are tackling section C, which consists of messaging type questions. This format is excellent for testing your ability in the associated algorithms and distribution with defining characteristics. We'll be connecting statistical distribution like binomial and Poisson to their unique mathematical properties, such as when the expected values equals the variance. We'll also draw clear lines between the different types of errors, distinguish between the reducible error and the irreducible errors. Furthermore, we'll match machine learning algorithms like linear regression and k-means to their primary functions. And we'll also map big data tools like Yarn and Spark to the specific role in Hadoop ecosystem. So let's match these up and lock our understanding of the questions. So hello and welcome everyone. Uh, I just Let's just start with section 3 of our internal assessment 3 of data science. So here we begin with question 26. Match the distribution in column 1 with the key property in column 2 and choose the correct answer from the options given below. So first one, in the first column, we have binomial, normal, Poisson, and power law. In the column one, basically we have the various distributions available in the data science. And in the column two, we have EV is equals to NP and variable is equals to NPQ, bell-shaped symmetrical, EV is equals to variable is equals to lambda, and the fourth one is long case and Pareto. So correct answer is option A, A1, B2, C3, and D4, which maps to binomial. EV is equals to NP, variable is equals to NPQ. For normal, it is bell-shaped and symmetrical. For Poisson, it is EV is equals to variable is equals to lambda. And for power law, we have long tails and Pareto. So the binary distribution has expected values NP and variance NPQ. The normal distribution is symmetrical and follows the famous bell curve. And Poisson law, Poisson has equal mean and variance, defining property of the model. And in the end, the power law distribution exists long tail behavior, which is commonly seen in wealth, popularity, and network data. Question 26. Match the terms with definition. In the column 1, we have reducible errors, irreducible errors, overfitting, and underfitting. In column 2, we have cannot be reduced, high variance, model noise, can be minimized by better technique, and high bias misses relationship. So the correct option is option A, A3, B1, C2, and D4, which correctly maps to uh, reducible errors to third option, which is can be minimized by better techniques, and irreducible errors to cannot be reduced. And overfitting is mapped to overfitting C is mapped to option 2, which is high variance and model noise. And underfitting is mapped to option 4, which is high bias and misses relations. Now coming up on question 28. Match the ML algorithm in column 1 with the characteristics in column 2. So in column 1, we have following entries: linear regression, logistic regression, k-means, and decision tree. In column 2, we have just a minute. In column 2, we have clustering centroids, binary branching, which is prone to overfitting, predicts numerical, minimize RSS, and predicts probabilities or sigmoid. Correct option for this question is option A, A3, which is linear regression is model 2 predicts numerical and minimizes RSS. B4, which is decision tree is mapped to predicts probabilities or sigmoid. And C is mapped to 1, which is linear regression is clustering or centroids. And D2, which is decision tree is mapped to binary branching and it is prone to overfitting. Now, coming upon question 29, which is match the big data tool in column 1 with the functions in column 2. So the entries in column 1 are HDFS, MapReduce, Yarn, and Spark. The entries in column 2 are job scheduling, resource management, distributed file system, parallel processing paradigm, and in-memory processing RDDs. So the correct option for option 29 is option A2, which maps HDFS to distributed file system. B3, which means map reduce to parallel processing. C1, yarn to job scheduling, and Spark. D4, which maps Spark to in-memory processing. So HDFS provides distribution storage for massive data sets. MapReducer perform best style parallel processing on large data. Yarn handles resource allocation and job scheduling in Hadoop, whereas Spark offers fast in-memory computation using RDDs for iterable workloads. So we have successfully covered section 3 of our internal assessment 3. Now, in the next upcoming videos, we'll deal with section 4 and the final section, which is section 5. Till then, keep learning. So that concludes section C, and we have successfully cleared up the key concepts, ensuring that we know that K-means is for clustering, while logistic regression is for predicting probabilities. We also enforce the hierarchy of the Hadoop ecosystem, matching SDFS to the storage, MapReduce to processing, and Yarn to scheduling. A vital distinction for any big data engineer. Remember the subtle but important difference we covered, like how power law distribution relate to the long tail phenomena, and how overfitting implies high variance, while underfitting implies high bias. These associations are often the quickest way to gain points in exam if you know them cold. Take a moment to visualize these connections and then join me in section D. We will test our logical reasoning.